And in this lesson, I want to talk to you guys about something called refraction. Now, before I start talking to you guys about refraction, I want to tell you guys a story of when I was a little kid because I just have to get this story off my chest. Now, you guys probably think that I was born in New York or something, but you guys are totally wrong because I was actually raised on a desert island when I was a little girl, and this desert island had one tree with a couple of leaves, and this picture actually is looking pretty good right now. Pretty sweet looking tree. So here's me, Bucky, just a little lonely girl on a desert island surrounded with nothing but water. So here's the water right here. Water. I think that's how you spell it. I'm not sure. So one day when I was about, I want to say 12 years old, a boat was sailing past. Now this boat was a pretty cool looking boat, looked like that, and inside it was this beautiful girl named Henry. Henry. I know, weird names, but hey, it happened. So I wanted to get off the island and meet her, so I started yelling at the top of my lungs. Now, traditionally, whenever you yell to someone else, your sound waves would look something like this. Let me pick some colors that are going to contrast. Okay, yellow might look good. So the sound wave might look like this. Yay, yay, yeah, yeah. Hopefully you guys can see that yellow because it's, I know it's kind of light, but hopefully it shows up. Now, this is what typically would happen whenever you were yelling to someone, whether they were outside your house or in a parking lot or in a grocery store, something like that. But I knew, since I was, secretly studying physics on this desert island in my own time, that sound travels faster through warm air because it's easier for the air molecules to collide with one another. This is also why sound travels faster at different speeds, or excuse me, sound travels at different speeds faster through water because it's easier for those water molecules to pretty much smash into each other, transferring the sound energy. Same thing travels really fast through metal because those particles are so jam-packed together they can collide with each other really easy. Same thing is true with air and water. Whenever you get really warm air, I'll label it so you guys know what I'm talking about. Air, this warm air basically lets sound to travel really easy through it. Now, cool air, or I should write cold there, but this cool air right above the water lets sound travel through it, but much more slowly. So what exactly was happening with these sound waves? Well, these yellow sound waves was basically what should have happened. But since sound travels faster through warm air rather than cool air, this is what actually was happening. By the time the sound wave was supposed to get here, the top of the sound wave actually was a little bit ahead, and the bottom of the sound wave was a little bit behind where it should have been. Why is this again? Because it is traveling faster through the warm air and slower at the bottom where it's closer to the cool air. So the sound wave actually looked like that. Now, by the time it was supposed to get to the second one, the same thing happened, but even more so. The air was warmer, so the sound wave got to about here. Now, remember, like I said, sound travels slower through cool air, so the wave kind of looked like this. And they kept going on, and as you can see, instead of a default sound wave like we had in yellow, where would be the case if you're yelling in a field or in a parking lot or something, whenever you yell to someone over water, your sound actually bends. Now that's the definition of refraction, basically the bending of a sound wave. So if anyone asks you how can a sound wave bend, that doesn't make sense to me. Well, to recap one last time, since sound waves travel faster in warm air, sound near the water I keep saying transfer when I mean travel, will travel slower than the sound above it. So basically, this part of the sound wave is traveling faster than this part of the sound wave, creating sort of a bend. So since my sound was bending towards the boat, that means that this beautiful girl, Henry, could actually hear me more clearly than if we were both on dry land. So that's another cool fact that you guys, maybe you want to impress your friends or, maybe you have a girlfriend named Henry. If you're like, you know what, I bet that you can hear me better if you go out in a boat 300 yards and then I scream to you. So they're like, you know what, Bucky, I don't believe you. So then you send them out on the boat and you yell to them and you're like, hey, can you hear me? And they're like, yeah, I can actually hear you a lot better. And they're like, okay, see ya. And then you leave and they're stuck out in the middle of the ocean on a boat. It's an enjoyment for everyone. But anyways, that is what refraction is, the bending of sound waves. Hopefully you guys enjoyed that little story. Thank you guys for watching, and I'll see you next time.